Okay, this is the last example that we worked yesterday, or I had you guys work it and then we went over it together. For those of you who were not here yesterday, or if you're watching this video, you may want to pause the screen to finish working it out or take a picture of it or something, because I didn't show it on my recording from yesterday, me working it out. So take a second to make sure that you have this. If you just want to take a picture of it or pause it or whatever, and you'll be able to check your work from this. But we are going to work one more example before I give you guys practice problems. So this will technically be example 7 on this set of notes. Four times log base 2 of x, minus log base 2 of 5 equals log base 2 of 125. Zoom in some. 4 times log base 2 of x minus, log base 2 of 5. I didn't write that correctly. Log base 2 of 5 equals log base 2 of 125. Okay, so before we can use any of the other properties that we learned, there can't be any numbers in front of the logarithms. So we need to get rid of this 4 that's in front of this first logarithm. We can use the power property that says that 4 can be moved so that it becomes an exponent on the x. So all we're doing is moving this 4 so that it becomes an exponent on the x. The power property says we can do that. Everything else in the problem is going to stay the same for now. The next thing that I notice is that we have two logarithms that have the same base that are being subtracted. So the quotient rule tells us that we can combine these two logarithms into one logarithm. When we do that, the base stays the same, so it's still log base 2. But then when we write them together, we use division. So this is x to the 4th over 5. Whatever number comes first gets written as your numerator. The number that comes second gets written as your denominator. And that is still equal to log base 2 of 125. Now we've gotten it to where we only have one logarithm set equal to another logarithm, and they have the same base. When that happens, we know that whatever's here has to be equal to whatever is here. So in order to solve for x, we set those two things equal to each other. So x to the 4th over 5 equals 125. We want to get x by itself. Right now, the x term is being divided by 5. So to get rid of that, we need to multiply by 5 on both sides, so that these 5's cancel and just leave us with x to the 4th. And what's 125 times 5? 625, thank you. Okay, from here, you may not have seen this very often. Probably a lot of times you'll see x squared equals a number. So you know just to take the square root of both sides to get x by itself. It's the same thing here, except now it's x to the 4th. So we take the 4th root of both sides. The 4th root and this power of 4 cancel and just leave us with x. And then I'm going to show you how to do the fourth root on your calculator. Whatever root you want, you put that in the calculator first. So we want the fourth root. So we're going to enter 4. And then you're going to go to math. And it's number 5. It has x as the root. If you press enter, it takes your 4 and it puts it as a root. And then you can put in whatever number you're taking the root of. In this case, 625. Our answer is 5. Okay, we have another answer that the calculator is not going to give us. It's the same as if we were to take the square root. The calculator would only give us the positive answer. But another answer that we have is -5. Okay, just a little proof there. -5 to the 4th power is the same as multiplying -5 by itself 4 times. When you multiply -5 times -5, you get a positive 25 times this -5, -125 times -5 again would be a positive 625. So -5 is also a fourth root of 625. Anytime you have an even exponent, or you're taking an even root, your answer should include the positive and negative number. If it's an odd root, then that's different. You don't have to include both. Actually, you can't include both if it's an odd root. Okay, so we have x equals 5 and x equals -5. Now we need to go back and check to make sure that these are solutions. When you check, you have to go all the way back to the very first line of the problem. So let's check x equals 5. So we're plugging in 5 for x. So there's only one x, replace that with 5. Then we're looking to make sure that there's no negatives where there can't be a negative in a logarithm. Excuse me. We don't have any negatives in any spot where we're not allowed to have one. So we can go ahead and keep checking this. And the way that we keep checking it, we just follow the same steps that we took when we were solving. So move this 4 so that it becomes an exponent on the 5. Log base 2 of 5 to the 4th power minus log base 2 of 5 equals log base 2 of 125. The next thing we did was to combine these two logarithms into one. Log base 2 of 5 to the 4th over 5 equals log base 2 of 125. Set these two equal to each other. 5 to the 4th power over 5 equals 125. Okay, from here, we don't have to multiply both sides by 5 and get this number by itself. We only did that when we were trying to solve for x. Now all we need to do is just put this in our calculator and make sure it equals 125. So 5 to the 4th power is 625, divided by 5 is 125. So x equals 5 does work as a solution. So we go back over here to our answers, we circle x equals 5 as a solution. Okay, let's check x equals -5. In our first line, we end up with a negative where we're not allowed to have a negative number inside of a logarithm. So we stop right here. X equals -5 does not work. Even though if we were to keep going and move this 4 so that it becomes an exponent, that's going to change this to a positive number. But because we had to use a property to basically force this to become positive, that we're not going to do that. If the 4 had started out as an exponent, then we could keep moving forward. But because we had to use a property to force this to become positive, x equals -5 does not work as a solution.